Okay. So we want 25. Is that what we're thinking?
Yes.
Start there.
Yeah. Should be over.
Oh, Spencer, I still want you to show us.
20. I'll let Spencer help.
No.
Yeah.
You
Yeah.
shouldn't have said anything.
I don't know what I'm doing, Spencer.
Spencer.
She doesn't know what she's doing.
What'd you
man.
get?
You gotta help her out.
What'd you get on 25, Spencer?
I don't know.
Number 25.
I got 0.
The inverse tangent.
Supposed to be.
I don't know how to make ramen noodles. 0.
That actually was what it was
Of the
supposed to be.
sine of pi.
But how'd you do
It's
that? That's the
possible.
problem.
It's possible you're making it too hard.
I think
I just plugged it in and it got high.
Suck it.
it said without a calculator schema.
What? I didn't use a
It
calculator.
Say without a calculator.
It did?
Yes.
Yeah, girl.
Well, that's probably my
I
problem.
used to follow him.
Okay, let me make sure
1400.
Wow, I'm
Do not
struggling
bring
today.
this. Do not bring Satan's name back into this holy class.
Okay.
I like that.
Liam.
So what's the sine
You
of
know what
pi?
you said.
The sign.
Well, that's the first thing we have to do is
That's
find
a
the
sin.
sine of pi.
Very much.
So the sine of pi.
The whole page is a sitting place.
Okay, I could have done that one.
Right? So
That's less hard.
this is the ratio, right? So what angle will give us a tangent of 0?
0.
What is
No, remember it's sine over cosine. So where is the sine
Zero.
over the cosine? 1
Zeros.
or 0?
Zero sign. Your sign is equal to 0. What?
Whenever the sine is equal to 0,
Sine will give us 0.
so the sine of 0 is 0, right?
Yes. Over. If you divide
Do you have your, okay, put your unit circle out in front of you.
Michael,
Put
it's
your unit circle out in front of you. So remember, the inverse tangent, so this is the ratio. The answer is going to be an angle. So at what angle do we have a ratio of sine over cosine equaling 0? Because we need this ratio to be 0.
180 degrees.
Okay, so at 180 degrees,
Oh, because we're thinking of sine as like y. Okay.
Yeah.
yep,
And
and 0 degrees. Okay, so it's at 0 degrees and 180 degrees, or it's at 0 and pi radians. Okay, we're gonna further restrict that today, but that one was probably easier than you were making it.
okay.
Is that what you got, Spencer?
I got 0. I did
Nice work.
pi first.
Okay. Which other one do you want to see?
we do
I don't know which one's negative.
29, we sure can.
I did not get this one.
Okay.
Yeah, I stopped at 29.
Okay, so you didn't, you're not gonna help me, Spencer?
I'm sorry.
Spencer,
That's-
help her. Do it.
You can all help us, we can all do this together. Inverse tangent of the sine of, wait, where am I at? 29.
4.
Inverse tangent of the sine of 4 pi over 3.
So that's
Okay, so let's write that down. Inverse tangent of the sine of 4 pi over 3. Okay, so what kind of answer are we going to be looking for here? Angle or ratio?
Angle.
Angle. So our answer is going to be an angle. All right, so we're going to start from the inside and work our way out. So the inside is the sine of 4 pi over 3. What's the sine of 4 pi over 3?
negative square root of 3 over 2.
So, negative square root of 3 over 2.
Wait.
Yes?
Wait.
Yes.
Wait,
Yes.
yes?
Yes.
Okay.
It's
Okay.
just the y value.
I guess I didn't see that.
Not
So-
as smart as
So, is there a combination of sine over cosine, because tangent is sine over cosine? Is there sine over cosine that would give me the negative square root of 3 over 2?
Sounds like a trick question.
My knowledge.
There is not. There is no, I'm going to say easy here.
No, no easy way out.
So the only way to do this is to use a calculator.
Well, I guess it is an easy way
You
out.
also said use one and then explain why.
Oh, I didn't read that part.
Yep.
I
didn't read that part.
I just said don't use the calculator, and I was like, okay.
In the following exercises, find the exact value if possible without a calculator. If it is not possible, explain why. Because there's no ratio.
I thought that meant like, if there's no solution, explain why.
I see.
Yeah.
That's fine.
Okay? Other questions?
No, this man didn't read the directions.
Can we do? Yeah, I don't have 75.
Okay. The inverse tangent of 12 over 5?
Is it 6?
Well, it's the cosine. Should be 5 over 13.
I got 6.
Okay. You got something.
I have no idea.
All right, so let's do number 35. Okay, 35 is the cosine of the inverse tangent of 12 over 5. Okay, so I've got to find this inverse tangent of 12 over 5. Okay. I'm going to kind of go over here and sketch out a little triangle. Okay. So the ratio 12 over 5, tangent is opposite over adjacent. So it's not the hypothesis is really all we need to know, right?
Hypothesis.
What did I say? Hypotenuse. Sorry. Sorry, I had middle school science on the brain. What is she talking about? Okay. Sorry, middle school science on the brain.
Alex about to be watching that.
Okay. Hey. All right. So, but I can find the third side, right?
Yeah.
Yes.
I agree.
Okay. So 12 squared plus 5 squared equals c squared. So 144.
Yep.
All right. Plus 25 equals c squared. 169.
Nice.
You guys are so terrible.
College class.
Okay.
Discussion.
Square root of 169. You guys know this?
Nice.
3.
13.
Oh,
I was close.
Okay.
Oh yeah, because it's a 5, 12, 13 triangle.
Right. Right.
Wow.
So this is 13. So I want the cosine. So I want the adjacent over the hypotenuse.
Yes.
Yes.
Okay. So, well, what did we decide? Now we just need to decide like what's what. We know the hypotenuse is 13.
Yes. Right? So it's 5.
But then it could either be.
Oh, where's the angle?
Well,
I
but
don't know where
because
that
you
That's the
angle
thing.
put the it's gonna be in the bottom right.
Yeah, it
This
should be
is
by
your
the 5.
angle.
It should be 5.
So it should be 5.
Okay,
I got that.
that's what I was thinking.
Nice.
I mean, it's either 12 or 5. You got
Right. It had to be 12 or 5, but we chose in the beginning
Because tangent is.
Yeah, you're right. Yeah,
Adjacent
right.
over-
You got that. Yeah.
or opposite, whatever. Opposite over adjacent. Okay.
Alright.
Great.
That's
Done and done.
oh that's it.
That's it.
Oh, man, you got 10.
because we wanted the cosine of this angle, right? So we had to decide that this was the angle. We want the cosine of that angle, which is 5/13.
Oh, that's neat.
That's neat. Okay. Are we better?
Yeah.
Okay. So let's clear up just a little bit on those, on this inverse function business.
We're gonna have to listen to that.
That's good stuff.
Are you guys watching the clock? You have to leave at 2:30, right?
I have not been watching the clock, but now I am.
Okay.
We didn't like that.
2:30, that's when I go to the dentist. 2:30.
Got the whole squad laughing.
Welcome, Alex.
You missed it, Alex. You can catch the
Anyone
show.
else who watches this is gonna be like,
Oh my god, it's so, like, I can't even believe this is a thing. Okay,
We
so,
have to keep these videos for next year.
sure.
Boy, just screen record
For
when
just
you watch
like,
it.
Yeah.
we need a good laugh. Okay, so let's recall. Hopefully it's a recall. Maybe it's not.
we'll find out.
We'll find out. Some of the rules about inverse functions, okay? So in order for a function to have an inverse,
Boxcars.
I wish that was our camera.
let's turn it around. Okay, so in order for a function to even have an inverse, first of all, it must be a function.
Whoa.
Wow.
No. Which means it has to pass that vertical line test. Right? In other words, when it passes that vertical line test, it means that every x only has one y. Right? So every x has only one y. Okay, so in order for a function to even have an inverse, it has to be a function.
Yes.
I know that seems silly, but like it has to do these things. Okay, in order for a function to have an inverse, it also must be 1-to-1. Do you remember about 1-to-1?
Nope.
Great.
I feel like that relates back to chemistry.
Yeah,
Everything
don't.
has to be like one-to-one
Stop.
and stuff.
So 1-to-1 means it also has to pass a horizontal line test. Okay, so it has to pass a horizontal line test, which means that no two values of x produce the same y.
Oh, so it can't. Oh.
So it can't pass through a vertical or a horizontal line can't pass through the function twice in order for it to be 1-to-1. Are you already thinking that this doesn't work for the trig functions?
Yes.
Right, it does not.
I was about to say, doesn't-
That's why I told you yesterday we're going to have to further restrict the domain. Okay? So we're going to look at the sine and cosine and tangent. So here's the sine. If this is 0, 0,
And it already can.
right?
Oh,
Like,
Right, so this is what, pi halves?
sure.
Please. This is negative pi halves. Okay? And then cosine is gonna start here. Let me make sure I do hit this right. I don't even know what's going on back there, and I don't know that I care. This is tangent.
That's the only one that works. Yeah.
Okay?
Yeah, pretty good.
All right, so sine and cosine clearly do not pass the horizontal line test. So here's what we do. We restrict the domain of the function. For the sine, we restrict that domain from negative pi halves to pi halves.
I was about to say, it has to be like barely a period.
Right? It's not even a
It
period.
can't be a period, yeah.
It can't be a whole period because we're going to pass through, so it's really half of a period. Because has a period of 1 pi. The period for the sine graph is really 2 pi, so it's half of a period. Cosine we restrict from 0 to, let me make sure I tell you right, to pi, because this is pi right here. So we restrict the domain, and then for tangent, well, a horizontal line does just fine through between these two asymptotes. So we're just going to restrict it between these two asymptotes. Okay? Okay. So when I restrict the domain of the function, what have I restricted on the inverse? The range.
I only knew that because you were about to say.
I was about to say it.
Yeah.
Okay. So I've restricted the domain of the function, which restricts the range of the inverse function. So now we can only get answers for inverse functions that are between pi halves and negative pi halves for sine, between 0 and pi for cosine, and between negative pi halves and pi halves for tangent. So
I'm just gonna ask this off the go because we gotta go. Are we gonna have homework?
there is a homework assignment.
Okay.
It is 8.3, page 687, numbers 37 through 41, and 53 to 61.
I was really hoping we would stop at 37.
These are word problems.
Are they
Oh, they're super fun.
You lie.
all of them or just odds?
Just the odds.
Okay.
Just the odds for homework. Okay, boys. Get out of your heads and go make it happen.
Yes.
Where are you playing?
West Green.
Go have some fun.
Good.
We have it's districts.
Go have some fun.
Playoffs, here we come.
All right, so I'm gonna do a little chart for you.
I'll flip the switch. You can kill him like
Oh, flip the switch. Goodbye, Mr. Alex, if you're watching
Yeah.
this. I love you.
Hope you're doing great too, Alex.
that. Anyone else who's watching this is gonna be like,
Alex, you're a Sith.
Alex, you're a sim.
Yo, Liam, this quarter is still here from yesterday when I threw it at you.
Okay,
Goodbye.
you got this, guys.
Bro, it's New Jazzy.
Hi.
I'll take a high five.
Alright, I only give you high fives.
Bye, guys.
Bye bye.
All right, so the range of inverse functions are limited to. Okay, so we just did the sine inverse.
Calls, I'll just call back on Monday.
Okay, sorry, I didn't know if that was something I needed. Negative pi halves
On the top of my invoice,
to pi halves
the one is the,
for the inverse cosine,
and the other one is
0 to pi. For the inverse tangent, this is 90 degrees, right? Like you're limited to below 90 degrees, below 180, below 90.
Are we gonna need to know that?
Hmm?
Are we gonna need to know that?
Well, if you would get an answer that didn't fall within these ranges, then you have to do something different. Means you probably didn't, you have a mistake in there. Okay. Also, your calculator limits it automatically to these ranges. Okay. Your cosecant.
This is just like the paragraph.
No, so this is the range. So your answers for an inverse function.
Even with like phase shifts? Or is that not a thing?
Don't worry about that yet.
Yeah.
Don't worry.
Oh, God.
You're good. Don't worry. This is just when you're solving problems using your inverse functions, your answers have to be within these ranges. Okay? So your cosecant has a range of negative pi halves to pi halves, but y cannot equal 0. So you can't get 0 for an answer if you're trying to find inverse cosecant. The inverse secant has a range of 0 to pi. It cannot be pi halves. And the cotangent is between 0 and pi, and it's not limited, it can have whatever. Okay. So those are your ranges. Your answers when you're using these inverse functions have to be within those ranges. Okay. Okay, a couple of like cautionary tales real quick here.
Okay.
Okay, that is not the same as this. Okay, this is the inverse sine. Okay, this is the reciprocal. So just be careful. They are not the same. The inverse sine of x is the inverse sine of x. Sine of x to the negative 1 power is the reciprocal of sine. Okay? Second cautionary tale. If you have this, so a lot of you said yesterday, why can't I just put that on my calculator? Because you certainly can. You could do cosine, you could do 13 times pi divided by 6, get that cosine, and then take the inverse sine of that. What happens when you do that?
Not, like, accurate.
They're not accurate, they're not exact. Okay? You have lots of rounding and estimation errors if you just punch this into your calculator. Sometimes we're forced to. Sometimes that's the only thing we have left to do. But if we don't have to, if we don't have to get a rounded answer, we want to get an exact answer. So here's on this one, we call it direct evaluation when we want like an actual answer, not a rounded answer. Okay, so this direct evaluation is going to be better if it's at all possible. Okay, so I'm going to take the inverse sine of this cosine of 13 pi over 6. Well, the cosine of 13 pi over 6. What do we know about that? What do we know about 13 pi over 6?
A Pythagorean triplet. Isn't it 6, 12, and 13?
No.
Oh, good.
Is it?
It's not what I was looking for, but
Oh, so
it's 5, 12, 13. Darn it.
so
You have to go back to like the first or second section.
We need a reference angle?
Yeah, this is more than once around, isn't it? 13 pi over 6. Well, 12 pi over 6 would be once around.
Yes.
So if I did 13 pi over 6
That's 390 degrees.
minus 2 pi, which is one full rotation,
Pi over six.
revolution, that gives me pi over 6. So 13 pi over 6 is exactly the same angle as pi over 6. Now the problem's easy. So now I have y equals the inverse sine of the cosine of pi over 6. Well, what's the cosine of pi over 6? It's on your unit circle.
Well,
Well,
Root of 3 over 2.
square root of 3 over 2.
it is. So now I have y equals the inverse sine of square root of 3 over 2. Remember, this is the ratio, so my answer is going to be an angle. So what angle has a sine of the square root of 3 over 2?
120.
30.
60,
Oh,
or pi over 3, is that, we're looking at inverse sine, so is pi over 3 between negative pi halves and positive pi halves?
Yes.
Is it in the first quadrant? Yes. So the answer then, y equals, what did we say?
60.
60 degrees, or pi over 3 radians. Okay? So using direct evaluation, we were able to find the actual answer, whereas if you had done it on your calculator, you might get something close to whatever decimal pi divided by 3 is, but you're not going to get the exact actual answer. Okay? All right. Let's look quickly at an application or two.
or we don't.
We do.
You don't need words.
These are the fun ones.
No. I hate word problems.
I like this class because we got rid of the words. Now they're back.
Well, the words are back.
I like words better than individual letters.
There's that. We all have things we're gonna love and things we're gonna hate. So,
Miss
She tried to trick us so many times with the words. I'm done with words.
but there's all so beautiful.
No. The numbers are good.
The numbers are
this
good.
is not.
All right. Which one did I do here? Suppose you drive 0.6 miles on a road. So I'm driving 0.6 miles.
Yeah, it is.
So that the vertical distance changes from 0 to 150 feet. So here's the vertical distance. This is not to scale, clearly. And this is the road. Right?
Right.
Okay. What is the angle of elevation of the road?
Well, it would be 0.6 over 150 in the, reverse tangent thingy.
Reverse tangent, because we have opposite over adjacent. So the inverse tangent is 150 feet.
We have to convert it.
You have to convert it. So I'm going to convert the miles to feet because that'll get rid of my decimal. So 0.6 miles, 1 mile is 5,280 feet. So that gives me an answer of 3,168 feet. So I'm going to change that. So then I just divide those. 150 divided by 3,168. Actually, I guess I just put it in my calculator like that. So then you just put inverse tangent, and it opens the parentheses. You put 150 divided by 3,168. You close the parentheses, hit enter, and you get theta equals 0.47 radians if your calculator's in radians. If your calculator is in degrees, you're gonna get 2.71 degrees.
It's not very many.
So that's when you have to know what your calculator's in, so you know what label to give your answer. Okay? And did I do any more? Did I just say forget it?
Forget it.
No, I thought I did another one.
Do we
I
have?
did.
Oh.
Maybe I just figured you could do the rest of them,
That's nice.
because you're smart like that.
Mm-hmm.
I guess I did.
I don't know, Julie, these people didn't do their homework last night.
I felt like I did a whole bunch of problems.
Didn't do it right.
Know how to do it.
No, you guys are fine. Okay, so you're gonna do 37 to 41 odds, 53 to 61 odds. 53 to 61 are those word problems, but I'm pretty sure you can do it. Okay?